This is the free response question from 1971 on solutions for the AP exam. If you haven't worked on this problem on your own yet, I highly recommend that you pause or stop this video, work on it on your own, and then come back and see where you could have gotten some points. Now, this question is from earlier, 1971 was a while ago. Back in the day, when you took the AP chemistry test, you had many more free responses to answer. And so those free responses are slightly shorter. So 1971 and some of the other ones you might watch from the 70s are shorter questions. And also, the grading data for them is not available. So I'm going to estimate where you would have gotten points for a question. And most of these questions are going to be worth only a handful of points, because usually solutions come up in multiple choice or as parts of other units. So this is a good overview for you before you take the exam, the solutions unit. That being said, give this problem a try on your own, and then come back and see what you got in comparison to what I got, and let's see how we do. So the first thing this says is molarity and molality are two different ways of expressing concentration. Clearly distinguish between the two of them. So you've got to talk about both. Molarity, symbolized with a big capital M, is moles of solute per liter of solution. You can abbreviate solution SOL''N. It's a well-known abbreviation. Molality, lowercase m, is moles of solute per kilogram of solvent. As I said, the scoring data for this is not available, so I have to estimate what you would get points for. I'm assuming each answer would be worth 1 point. You could have expressed it mathematically like I did, or you could have expressed it in words. Molarity is the moles of solute per liter of solution. Molality is the moles of solvent per kilogram of, moles of solute per kilogram of solvent. Either way, as long as you mention those variables, you should get the points. Indicate an experimental situation where expressing concentrations as molarity is particularly appropriate. So, where have you seen us use molarity before? We've used it in acid-base titrations. We use it when doing dilutions. Pretty much any experiment at which temperature does not change. So there's a large number of answers here, but the key thing is any experiment in which temperature is constant. No, I was not about to spell constant with a K, but we sometimes abbreviate constants with Ks, but let's just be a little more thorough. So any experiment in which temperature is constant is a valid answer for this one. The reason temperature has to be constant is because the volume will change with the temperature. Things that are hotter expand and take up more space, so your solution will take up more space and your concentration will change, and therefore that's an issue. So any experiment in which temperature is constant, so acid-base titrations, dilutions, something in which the number of moles is what you're really after. All right, for this one, I believe it's just 1 point. I wouldn't imagine there'd be anything else, because it doesn't ask you to explain why it's important. So any one of those experiments listed, any one of those experiments you can think of in which temperature is constant, is most likely worth 1 point. All right, so lastly, indicate an experimental situation in which expressing concentrations as molality is particularly appropriate. So for this one, one of the most glaring ones you can think of that we use that lowercase m for would be colligative properties. So osmotic pressure, boiling point, elevation, freezing point, depression, molar mass from those. Again, with this is going to be the opposite. Any experiment in which temperature does not need to be constant. All right, so if you could think of any large number of answers you could choose from for that. And once again, I believe that would most likely be worth 1 point. So for a total of 4 points on this question, remember half is enough to get you that 3, 4, or 5. So if you just got the first one, that's probably enough to do it for you. But this was a pretty easy question. This is most likely something that would show up in a multiple choice rather than a free response.